Just want to introduce these guys. It's Tim Strazzeri, Anthony Lineberry, Tim Wyatt, and you can feel free to call any of their Tims the other Tim if you would like. You're at the mobile track, and their talk is called "Don't Hate the Player, Hate the Game."
So as I was just so kindly introduced, I'm Tim Strazzeri, and you can call me different Tim or other Tim or anything like that. That's the original Tim. So who are we? We're just a bunch of hoodlums. Sorry? So we're just a bunch of hoodlums from Oakland. Anthony actually runs HoodSec, so if you're ever in the area, you should come by, drop us a line. We all work for Lookout Mobile Security. We're on the security team, clearly. And yeah. So today we're basically going to go throughout this presentation, we're going to discuss about the Android platform, how patches are introduced into that platform, and then we're going to talk about how we track that on devices and the critical vulnerabilities of Android that have already come up in the past. From this data we've gathered, we can see some interesting metrics on the exploit half-lives, and I think it's pretty interesting. So to start off, we're just going to go into a little background about the Android platform. To understand how patches work in the ecosystem, we first need to know what exactly we're patching and what are the components of this system and how the ecosystem actually works. So as we can see, the Android project is pretty complex. We have lots and lots of lines of code, and in the blue you can see the external open source libraries that are included into it, and in the red that is Android specific code. So included in that blue, we have over 115 open source libraries that are actually bundled and shipped onto production level devices. We weeded out test libraries and other libraries that actually aren't shipped on devices. So you can see actually from the left-hand side, we have Cupcake, and then we go all the way up to Master, which is where Honeycomb is presently residing. And we can see through that whole entire thing, about 60% of that code is, again, the open source libraries. And then as we look deeper into that code, like what is that code? We have NCC, we have C++, and we have Java. Java is in the green, C++ is in red, and NCC is in blue. So we can see that over 60% of the code is consistently native code. This is where you often find many of those exploits. So we can see that the trend continues that much of the native code much of the Android platform is based in native code. So if we want to look at the system, we need to see, have we seen any CVEs so far? So in 2010, we actually have no recorded CVEs that include privilege escalation. There were 2 actual exploits that were released, both Exploit and Rage Against the Cage. They were not assigned CVEs though. In 2011, we have 6 accepted CVEs thus far. We have Killing in the Name Of, which is also known as PS Neuter, and we have Gingerbreak. And those 2 specific exploits do allow you to root the phone and gain those extra privileges. So moving on to the ecosystem, as we can see, it's kind of complicated. We have Google, and we have them working on their private branches. This is where they keep their branches. Currently, Ice Cream Sandwich is in their private branch. Nobody else has access to it. They're submitting new features into that, and they're working on it behind closed doors, essentially. Once Google is done with this, we have 2 places that it can go. It can go into the public Android open source project. This is where they normally dump all their releases, and then everyone in the community gets to use those. And we actually have had with the Honeycomb release, this was actually dumped into a private Android open source platform branch. This was strictly given to Motorola for the Zoom to feature it strictly on that device. But that is actually the only branch that's happened on. We're not sure if that's going to happen with Ice Cream Sandwich or future versions. From there, we basically have people pulling those trees to go to OEMs, to carriers. They use this to build their firmware and their updates, to ship on devices, to issue OTA updates and whatnot. We also have app developers that get this API level. They get to create new applications for all this, and that only occurs once we have it issued into the public branch. The mod community also gets this. As soon as we push that code to the public branches, people like Cyanogen, VillainROM, they end up getting to pull that right away and pushing like nightly builds and whatnot. And then after this, after all those firmware or OTAs have been issued, once the app developers get to make all those the games, the utilities and whatnot, that then can get pushed to a consumer handset. Another important part of the platform is the compatibility test suite. Prior to releasing pretty much any update, no matter how big it is or if it's a new release, a OEM or a carrier must pass this test suite. It's basically to ensure compatibility with all the applications that developers are creating, and to make sure that people aren't breaking the phones, they're not changing the internal frameworks, and then things that are meant to work just stop working. What's been added into this suite of tests is actually a really great thing. It's all the security-based tests around this. These tests include things like checking for set UID, native applications, check to see if there are any bad signers on the device that we don't want to ship with, debug signers, test signers, and recently we've even seen the addition to checking for vulnerabilities, like the gingerbread exploit is actually being checked for in the CTS suite. When a OEM performs this test, they are not allowed to actually have their release certified as Android compatible if they fail these tests. So if they were going to release something, it needs to pass this 100%. Otherwise, Google calls this a Android-derived release. So it's not actually Android compatible, and they're not allowed to use things like the Android trademark. So now what I'm going to do is I'm going to go into how we ended up tracking these patch cycles and what information we've used to track them. Basically, why did we want to do this? Well, we're nerds and we like that kind of stuff. But on top of that, we just like the mobile patch cycle. Like, what actually is going on? We know people say, I want cupcake, I want donut, I want all these ice cream treats. But what does it actually mean? Do they just get new features? Are there security patches really getting rolled into them? What happens to these exploits? When do they disappear? It's important for us as users and as admins, as carriers and OEMs to realize what's going on with these security patches. If none of them are getting fixed, then we could be at risk. What is the exposure to these exploits? And then two specific questions that we're looking to answer are, where are we now? Android's been out for a while. We've had some excellent releases that have come out, but how are we doing on patching? Are we actually patching these vulnerabilities? And then where are we going? Are we on track? Are we getting better? Are we getting worse as the time's been going on? So how do we collect this? Essentially, we've used our product Lookout. We've been collecting anonymous aggregate data. There's no individual user data. We cannot tie this to individual people. And every time the device checks in, it lets us know little things like what's the firmware, what is their device model, and what's their manufacturer. We have over 10 million unique devices seen. And so this gives us a good sample set to look at with all these different new Android devices that are constantly being released. So essentially, we identify the builds. So we have this code that basically goes in, and each device has this build ID code. It's a short identifier, and it's set on in the get prop in the actual system. And it basically looks like that one down at the bottom, which is FRG83G. This is a significant one because this is actually the last Froyo build that was built by Google and certified. And it's actually broken up into the family, which is the first letter. The second letter is the branch. We have the quarter since Q1 2009. That's the first release of Android. And then the day within the quarter that was released, and sometimes there's a minor revision. So to continue with identifying these builds, inside the actual Android open source project tree, there's these tags. And the tags are basically a declared snapshot that has been tested by Google and that has essentially been certified by them. And we can map these directly to that build ID so that we know exactly when a phone has that build ID that it is with this tag. So to identify the vulnerable builds, what we've done is we've mapped all these security fixes back to the Android open source tree. We've done this, and we now know exactly which tag that is in. And then we map devices using the build ID to what what tag it actually has on it. So we give basically the priority to the specific build ID. One little caveat that we have found is that if people are cherry picking fixes, we did some spot checks for this, for instance, Gingerbreak. There are some devices that have backported that fix, so it doesn't match up with the actual tag, but we have accounted for that in our data. So I'm going to turn it over to Anthony for Android patching and how it works.
Thanks, Tim. So when we find a bug in the Android open source tree, one of the first things that's going to happen is Google's going to commit a fix for that into their internal tree. Obviously, that test is going to be reviewed before it merged in. There's actually a site, I don't remember the URL, but you can actually check out what's being reviewed, the various patches, things that get rejected and what gets merged in. And that's actually a great way to find vulnerabilities that have been patched in the tree before anyone really knows about them. And a lot of times they'll take these fixes, if say they patch something in Gingerbread and it also affects Froyo, they'll end up backporting that to 2.2 after the fact. At this point, the OEMs will grab a stable branch that Google has tagged, and that's their starting point for their modifications. And if there are security fixes that are available in newer versions, they will sometimes take those and cherry pick them into their trees if they haven't been backported by Google. At this point, they'll compile the firmware, put it through a lot of internal testing. They have various certifications that they need to pass before they can ship this off to the carriers. As we mentioned, the firmware must pass the CTS suite before we can really go forward with it. So after the OEMs are done with their build, the carriers get this, and they'll add their own stuff on there as well, applications that they want to ship, etc. They obviously do, because they're in charge of the infrastructure, they're going to do a lot of testing to make sure this isn't going to cause everything to come crashing down. Once we make it through basically this gauntlet of testing, we want to push the firmware out to the consumers. So this will either make its way to the consumer as a already flashed ROM when they buy a new device, or as an OTA update. And the user can accept this update or not install it. And there are certain cases where people won't necessarily want to install these updates. So we have this entire basically a community of people that they want to be able to use these vulnerabilities as a way to open up their devices. The OEMs and the manufacturers don't necessarily want you to be able to do whatever you want with them. And there's obviously a lot of fun things, customizations that you can do if you're able to unlock these. Most of these bootloaders are ship locked. There are a few in devices like the Nexus 1 and Nexus S where the bootloader itself is unlocked. Basically this means that in its locked state it's still going to do check signatures of the images that are being pushed down to make sure that they do in fact come from the manufacturer or the carrier. But from your computer, you can plug your phone in, use their tools, and unlock the bootloader so that you can flash on your own custom ROMs without having to use any vulnerabilities to do this. So as we said, in the modded community, vulnerabilities are looked at completely different. This is a vehicle for them to unlock these phones or root them. And a lot of times the entire community, they kind of just ignore the security issue around it and don't really pay it any mind. Another problem with these issues, or with the vulnerabilities being used for this, is that obviously if you find 5 ways to root a phone, you're not going to release those all to the public right away. You're going to sit on those, and as one gets closed up, then you're going to trickle another one out. And we've even seen instances specifically where Gingerbreak, Sebastian Kramer, the guy who originally found that bug, I believe in his blog, he said something along the lines of, I have an exploit for Gingerbread, but I'm going to wait till a few more devices come out so that this doesn't get patched right away. So while all these people that are modding their phones with these exploits are having a great time, the rest of us are running around with phones that are completely open to a lot of undisclosed vulnerabilities. And you have to remember that in the big picture, the community surrounding these modifications are very, very small compared to the entire user base of Android users. So what if you have a phone that's already been rooted? You're running a custom ROM. Well, there's some other problems. Or no, that's the next slide. So one thing that is good about these custom ROMs is that you can actually get security fixes faster than you might from some of the OEMs because they're smaller teams building these, they're a lot more agile. They don't necessarily have to do all this testing and whatnot that the manufacturers are required to do. So they can cherry pick a security fix, put it into their ROM, and release an update with a very quick turnaround time. One thing, though, is that because of the nature of these custom ROMs, there's no way to do this as an OTA. So you have to manually update your ROM. But we have things like ROM managers that basically, as updates are released, you can use these to be notified and install the updates. So some of the bad things about custom ROMs is that much like some of the OEMs that add on a lot of third-party code into the source tree, a lot of the custom ROM guys will add in their own code as well. Special features, sometimes even in the kernel, application layer stuff. And we don't really know anything about whether they're using the CTS suite. I would hope that they do, but it's really up to them. And so there's no guarantee that anything that Google is requiring manufacturers to make sure that they're patched against, there's no guarantee that custom ROMs are going to be patched against that stuff. So let's talk about some of the critical vulnerabilities that we've been tracking through our patches. So one of the biggest critical vulnerabilities, in our opinion, is Sebastian Kramer, because he finds everything. As far as if you follow any of the Android root exploits, he's the guy who finds every single one of those. So some of the ones that we'll talk about, this is not actually one that was found by him. This is CVE 2010-1807. This is a WebKit NAN float parsing bug that allowed remote execution. This bug in itself didn't give you root, but this can be layered with a kernel bug, or if you exploit something that's using WebKit and it has permissions to access other data, you don't necessarily need to be root to do that, so you'll have access to that data as well. This bug was disclosed in 2010 in May and was actually patched in November of 2010. So there was kind of a large gap there, and it was only patched in 2.3 and was never backported to 2.2. But the reason for this is because 2.2 and 2.3 were never actually vulnerable to this bug because of some compiler settings. It only affected 2.0 and 2.1. The reason that they did end up patching it in 2.3 was just general paranoia, just to make sure that this wasn't going to come back and get them. So the next one, exploit. Once again, we've messed up a slide related to exploit. The information on this is for Rage Against the Cage. But what exploit was an unchecked U event, an unchecked origin of a U event that you could send from user space up into the kernel and manipulate some of the hot plug stuff in initd to execute commands as root. And so ignore the disclosure dates up on the screen right now. The actual disclosure was July 15th of 2010, and it was patched both in 2.2 and 2.3. They didn't need to backport it at that point because 2.3 hadn't been released yet. But that was 4 days later on July 19th. So Rage Against the Cage and Zimperlich. This was a bug that was exploiting a return value that wasn't checked in setUID. So essentially they were maxing out the number of processes allowed for a user. And the first bug, Rage Against the Cage, is in ADB. So they would max out the number of processes, and at that point when they would spawn another one and try to drop privileges, they weren't able to do that, and so it would just continue running as root. Now that was only exploitable locally, basically like plugging your phone in the computer and using ADB to exploit this. A lot of people took that exploit and were running it inside of APKs and thought that they were exploiting the bug in ADB, but they were actually exploiting a bug in Zygote, which was later released as Zimperlich, and it was the same idea that they were maxing out the number of processes allowed to the user. When they would try to drop privileges, it would fail to do that. This was disclosed in August, originally for Rage Against the Cage, and then in December for the Zygote bug, Zimperlich. And it was patched in 2.3 shortly after, on 27th of August, and actually they patched the Zimperlich bug a few days later, well before it was publicly disclosed that there was a bug in Zygote, and backported to that same fix to 2.2 at the same time that they patched the Zygote bug. PS neuter and killing in the name of, these exploits were actually found independently of each other. It's the same bug, and the release of one of those, I believe, is what prompted the release of the other. This was a problem with unrestricted access to some of the system properties through the Android shared memory. Basically, I believe they set a page as non-readable? Non-writable? It was non-writable. And so when they would do a check on ro.secure, which normally would, once it saw that that was set, it would drop privileges. Once it couldn't read that, then it just said, okay, I guess it's not set, and wouldn't drop privileges. This was disclosed in January of this year, but was actually patched last year in July, but then the backport didn't make it until shortly after the public disclosure of this into 2.2. Gingerbreak and Honey Bomb. These are a little newer ones. This was a bug in the Voldy. It was actually kind of a combination of two things. It was much like the exploit stuff, where it was an unchecked U event origin, sending a message from user space up into the kernel. But also that combined with there's an array that didn't do a check, and they would use a negative offset into memory to perform a arbitrary 4-byte overwrite. This was disclosed the beginning of this year in April, and was actually patched days earlier. And that's actually what triggered the public release of this. Is he had been sitting on this, waiting for more devices to come out so that it wouldn't get patched. And then as soon as he saw that it was patched in AOSP, he ended up releasing it a couple days later. The backport made it into 2.2 shortly after that. So now Tim's going to come back up here and talk about some of the malware that's been using these exploits.
Thanks, Anthony. So in the course of collecting lots of malware samples and whatnot, we have seen quite a few, a few and quite many variants of them that have been using these exploits. One specifically that many of you may have heard of, it was a big news thing. It was one of the first ones that was discovered in the Android market. It's been called Droid Dream. It was publicly disclosed on March 1st. And we've since detected over 60 different variants. Essentially what the developer of this malware did was he took known applications, some that were paid applications, and he basically pulled them down, changed a few things in them, changed the name around a little bit, created a bunch of different developer accounts, and then injected some code inside. That code actually would attempt to use exploit. If exploit failed, it would then attempt to do Rage Against the Cage, and it would basically gain root through that. If your device was vulnerable and you downloaded one of these, it would root your device, and then it would leave behind a SU shim. So basically, anytime they ever wanted to get root again, they could just call this application. It was just dumped into system bin under a not apparent name. It wasn't something that you would normally look at, and they basically could call that and just get a root shell any time they'd like. In these stats, we actually didn't include Droid Dream Lite. That's another variant that we believe is the same author. It has basically the same pattern, the same kind of command and control functionality, but it does not actually attempt to root the device, so we haven't included that in here. One of the interesting things that it does with root is it remounts your system partition, which is normally read-only, it's not writable. And once they do that, they actually push applications to system app, which will install an application as a system application. And then when you reboot that phone, if you were a user and you said, hey, I didn't actually have this on my phone, and you went to remove that, it would actually disallow you to do that because that partition has then been remounted as read-only. So you couldn't actually remove that application. The next one that we've looked at, it was BaseBridge. This was actually found on March, or is disclosed on March 17th. We've detected over 10 different unique variants. It's similar to Droid Dream. What they did is they also found some applications that were popular, some games and whatnot, and some utilities. They decompiled that. They injected some more code in there. And they also included the Rage Against the Cage exploit. Again, they didn't actually include exploit, which Droid Dream had done. So this one will also attempt to root your device, and it actually pushes a second payload to the system app directory, using that same functionality that Droid Dream attempted to do, which is basically remount that and then push it there, and then you can't actually try and remove that next time.
The altered apps were distributed via the official.
Good point. Thank you. So this one was actually not found in the Android market. This one was in alternate markets, predominantly found in China, and then it went a few other places. We tracked it, but it looked like people may have just said, hey, there's that free game I'm looking for, and tossed it over to the side. Droid Dream, this one was actually found in the Android market. We've found many variants outside, but this was the first big one that was found in the Android market. Thank you. The next one that we also looked at, this one is called Zhash. This one was found, to his point, it was found in the Android market. It was not actually exploiting devices in the Android market, but it did have the functional code, but it was not calling it. This was found in an alternate market, the same exact developer, and it did have all that same exact code, and it could exploit, and it did attempt to exploit the devices. This was publicly disclosed on March 20th. We've detected about 3 different variants of it, and this one attempted to use only exploit. It didn't use Rage Against the Cage, and this one also left behind a SUSHIM. The interesting thing about this one, it doesn't appear that the developer meant to do this maliciously. He was actually attempting to gain root privileges so that he could change a few different settings in your secure settings that you weren't actually allowed to unless you had root privileges. So once he did this, he left a backdoor on your phone, which is not good at all because then anyone else on the entire device could then call this and basically get root on your phone. And he also didn't tell you that he was doing this, so that's a very bad thing to do. Next one that we have seen would be Legacy. This is also known as Droid Kung Fu, and there were other variants also found that were then labeled Droid Kung Fu 2. They're essentially, we believe they're all the same developer, and a few of these I believe were discovered in the Android market. and we found many of these outside of the Android market. We found approximately more than 50 of these different variants, and this was first publicly disclosed on April 4th. This one is similar to Droid Dream in that it attempts to use exploit. If exploit fails, it will then go over to Rage Against the Cage. If either one of those succeeds, it now has root on the device, and it can perform any of its command and control functionality. Things like it phones home, it attempts to install applications without your knowing, and this one also does that second stage payload where it's going to remount the system, and then it's going to push an application to the system apps. The last one that we've looked at is a relatively recent one. It's JSMS Hider. This one is interesting specifically because it uses a compromised platform key. It was actually using the key that is tested, that is for testing purposes and debugging purposes in the Android open source platform. We found over 8 different variants of this, and basically what it does is since it's signed with your platform key, and this was only affecting some custom ROMs. It was not affecting a normal device that you would buy from a carrier or whatnot. But basically, if your device was signed with the same exact platform key, it would then gain extra privileges. These extra privileges, most importantly, included being able to install something on your device without asking you, do you want to install this? It could just basically silently install this in the background, and you never actually had to confirm this or even know that it was being installed. So next up, Tim Wyatt is going to discuss half-lives with us.
So all of this is set up for the data that we're going to be talking about today. What we want to get to is, there's a long tail on the life of a release. There have been a number of different releases of the platform and different OEM builds that are based around releases of the platform. And these things come and go, but they tend to stick around for quite some time, even as they decrease in prevalence. So we wanted to look at how many weeks does it take for 50% of devices to get updated to a patch level that we can map back to the tree as having some of these vulns addressed. So this is kind of the overall picture of the Android release family, and we can definitely see that there are a lot of things going on here. And you can see releases come and go, but they do stick around. And the overall composition of releases that are actually live on devices over time tends to be stratified across several different versions of the platform, each of which ultimately have different security characteristics based on the patch levels that we're at. So let's have a look at a good release cycle. And if you look at the Nexus One, the way that we're mapping these things, it's kind of the key that we're mapping everything else to, because the Nexus One consistently over time has been the first device that's gotten an official build of different snapshots from the Android tree. So it's pretty good example of what can be done right. The patches come out quickly, and they are rolled out to a fairly substantial portion of devices in relatively short order. You can see, looking at this, they're kind of different intriguing characteristics of some of these things when you're looking at them. You can kind of see here that Google has a tendency to do incremental rollouts of builds. So you can see that things kind of start up and then they gradually ramp up on a number of devices.
Is this data worldwide or is it just US?
Yeah, so I mean, some things that we should keep in mind here when you're looking at this is that this is Lookout's view of the world, and so obviously, it's heavily biased toward the characteristics of our user base, and we think it's a relatively large sample, and that's interesting. But to your point, this is predominantly going to represent U.S. users. We do have a significant base of users that are abroad, but it is weighted towards U.S. users and devices. Ooh, excuse me. There are less exemplary release cycles, and there are devices out there where you essentially see a release that has let's say less than desirable characteristics, essentially an Eclair device that just stays out there as Eclair. Another, good example of a release cycle, the Motorola Droid has actually had a pretty regular release cycle. And if you look at this, we found it kind of interesting because it looks like it's pretty much trying to map to roughly a 12-week release cycle, and there's a little give and take around that where things slip out a little bit and then they pull it back in. But it's been pretty consistent over time. So if we look at specific devices, we're only going to look at a couple of specific devices, just specific devices, and that have interesting characteristics here. We're mostly going to look at aggregate data across different OEMs. So let's look at the Nexus One, and when we're looking at this stuff on the top here, we have the chart of different releases and their prevalence amongst the user base. On the bottom, we have basically what amounts to a decay plot of how different vulnerabilities affect devices as these updates start to take hold. So we're going to go through these characteristics, and we're going to look at effectively what is the point at which we achieve 50% uptake on updates. So if we look at the Nexus One, and we look at in particular how this WebKit vuln has been patched, it's worth noting that essentially so this was fixed in 2.2. So this is a bug that we're going to see the uptake on patch devices is roughly going to track the uptake curve from pre 2.2 releases through 2.2. So we can see that 2.2 begins rolling out with FRF 86B, but it really only gained steam with the FRF 91 release, which was kind of the first primary really big push of the Furrier platform app. And uptake is pretty quick on that, and so we hit the 50% mark. Exploit was patched pretty quickly, but it didn't make it out into, well, it was tagged for an FRG22D build that saw a very limited release. One of the things that I should also mention about the way that we cooked this data set is that we primarily focused on devices that where we weeded out anything where we didn't see at least 10,000 devices and where it didn't represent at least 2% of the overall user base at a given point. Just so we could focus on kind of the top, most interesting things where we have a good sample set. So we didn't really see much of the FRG22D release. So this didn't actually really start to get patched until the subsequent FRG83 release came out. Rage Against Cage and Zimperlich are going to tend to track each other pretty closely because while I think that they were patched a ways apart, the public releases that they were actually fixed in are really down along the same lines. So you tend to see one is prevalent until they both disappear. And it took basically 26 weeks for half of the devices out there to check in on a revision that we call patched. And for killing of the name of the Ashman Bowl, it got a little bit better uptake there. It was actually disclosed after it was patched in the gingerbread tree. So while the bugs were fixed then, we don't start to see patch uptake on it until gingerbread starts to get traction. And gingerbread things got a bit better here, and we only went 3 weeks before for a patch to be available on the Nexus. So overall summary of things: we have 9 weeks on WebKit, we have 12 on Exploit, 26 on Rage, and killing the name of 9 weeks, 3 weeks on gingerbread. So the overall Google device is pretty much dominated by the Nexus One. These things are essentially the same. I mean, the Nexus S is rolled in here too, but it's a far less prevalent device in our data set. And so these things really end up tracking each other pretty closely. So looking now at the overall characteristics of HTC devices, we can see it's a little less frequent of a patch cycle than the Nexus One is. But overall, we see things pop up, gain a lot of prevalence, and show up in the tree. So again, looking at the WebKit, we have 9 weeks basically before we start to see 50% uptake on Froyo. So yeah. So devices that report FRF91 actually carry the majority of what we've seen from HTC devices well into this year. This starts to swing down as we see devices that are reporting gingerbread, but we don't really see it drop below the 50% mark until 49 weeks into past disclosure. And for Rage Against the Cage and Zipperlick, we're getting there. But we still haven't seen it pop out. Now, we've spot checked devices, and we can definitely see that particularly some of the devices that are shipping more recently have actually had the fixes cherry picked down. So we did work something into the data set here where we can basically track that as kind of a separate point and do some accounting for that. Yes. I think that's hard to say, and there are a number of factors that could be going on out there. There are certainly some OEM devices that at least in our data set are going to be more pinned back to particular carriers, and where there may be some factor there. There are definitely OEMs that tend to have devices spread across multiple carriers, so we may see some differences there, and there's just user choice in some cases. Are people actually taking an OTA update when it's available or not? And it's hard for us to have insight into that. The insight that we have is what builds are checking in amongst our user base. And Gingerbreak, well, we'll see what happens here. But it's definitely still fairly prevalent. I mean, the thing about Gingerbreak is that while it's by no means, at least in released form, sure thing on most devices, there are a number of builds out there that it's going to impact. So we're primarily probably going to see it fixed in Gingerbread builds. So overall, looking at HTC devices, we have 49 weeks for WebKit and exploit, but we still haven't achieved the 50% mark on some of the other things that are out there. So looking at Motorola devices. Overall, now the Motorola release cycle is a mixture of builds that specifically identify themselves in ways that map back to the Android tree. But there are also a number of builds where there are a number of devices out there that report basically a stable branch name or just a just kind of a primary version name that we are basically mapping back to the stable release branch of the tree. So we see some of the characteristics are we're making some assumptions here about the frequency of updates, and I think those hold based on information that we based on what we see from testing specific devices, and just kind of assuming that the characteristics that we see very specifically on the Droid are somewhat prevalent across the more mainstream devices. One of the other things, though, is that there tend to be a lot of devices out there that are just stuck on relatively old builds of the tree. So accounting for all of that, we're seeing 16 weeks to hit the 50% mark. Froyo started to roll out for Motorola devices with FRG 01B, as well as a number of devices that just report Froyo builds. So we're basically seeing the WebKit flaw hit the halfway mark with the uptake of 2.2. For exploit, and I think this probably speaks somewhat to the prevalence of the droid at the time. There was it only took about 8 weeks to actually hit 50%, even though a significant part of there's a number of other devices that add up to a different set of builds that are likely still vulnerable. We're getting close on the Zygote and ADB-D vulns. The Zygote one is kind of the more interesting of the two because it doesn't require that you're tethered. And we're also getting there mostly as Gingerbread starts to take up on the Ashmem bug. So early Gingerbread builds that are coming out are reporting build ideas that seem to be patched. We're probably giving a little too much credit to the stable branch here because spot check devices that we see on 2.2 still seem to be vulnerable. So we think that Gingerbread still has some significant life to it on Motorola devices. So again, 16 and 8 for the two where we've reached a half-life point. And we're still sitting at something approximating infinity here. We'll see how Gingerbread plays out. So we don't have a ton of data on Samsung devices. So we actually have a pretty substantial number of Samsung devices that we have data on, but they all are basically reporting stable branches. So consider that when you're looking at these charts, we're looking more kind of at what the lifespan is of a group of related things within a major release when we're looking at the data on these devices. With very, very few exceptions, they just basically report the stable branch. So having said that, we can see here that it basically took 47 weeks to get to the 50% mark on 2.2. Just to be consistent here, we're going to kind of track this as the half-life of the WebKit NAM bug. For exploit, it took 37 weeks, and for 30, and we're basically looking at 30 Gingerbreak, well, we're assuming that things are going down as we start to see Gingerbread releases come up. We're also assuming that the majority of 2.2 have not been patched out of cycle specifically, and that could be wrong. But we get to 47 weeks for the WebKit. 37 weeks for exploit, and 30 weeks for reagents input. So LG devices are kind of interesting. They're less prevalent than some of the previous OEMs, but it seems like once they adopted Froyo, they seem to have tracked the stable releases pretty closely. They're actually reporting the stable release build IDs. So we're not really digging into specific devices today so much as the aggregate numbers, but it is interesting because some of their devices rev quickly and others tend to just come out and sit there. So having said that, at the end of 2010, Froyo hits 50% of devices, and as we've seen, the WebKit bug ends up 50% gone. That's 35 weeks after the first devices ship from LG. FRG83 starts rolling out in November, but doesn't really take until well into 2011. Everything else, we're basically sitting at infinity. We reached a certain patch point on the 2.2 release uptake and haven't gone past that. So we have 35 for WebKit, 28 for exploit, and nothing for everything else. Huawei devices, we kind of called out a specific case of something sitting there and just essentially not being patched. I mean, we see that basically the vast majority of devices that we see check in, at least, are all reporting ERE 27, which was the last, I believe, stable Eclair build. There's some noise in there about other releases popping up, but there's been very little uptake on those. So essentially, we're looking at infinity across the board here. And Sony devices. With Sony devices, we also see very little revision. We basically see things that identify as Donut and then Eclair that make up the vast majority of builds. We've started to see Gingerbread pop up, but unless the fixes have been cherry picked down and these have not been spot checked, then we are still looking at vulnerable build IDs, even though we see a couple of revisions in here. So we're stuck here as well. So one of the questions that some of the things that we were curious about are whether there are any other interesting characteristics of the data. In particular, are popular devices likely to get patched more? And are less popular devices, more vulnerable by extension? So these curves have confused just about everyone who has looked at them, including me at some point or other. So let me try to explain what we're doing here carefully and see if I can get it right. So we're basically going to look at a plot of the total market share in our data set. We'll call that market share that a device has. And so we can see basically that in this case, looking at this curve, the top 10 devices are responsible for 50% of the total market share. So if we look then and we say that the top 10 devices are responsible for 40% of the exploit vulnerable devices, then we can see how vulnerability kind of tracks this popularity curve. So we can see that that it's kind of riding pretty much alongside of it here. If we look at CV 2010-1807, then effectively one of the interesting things here is that we're kind of looking at the ratio of 2.2 to 2.1 and earlier, the way that we're looking at things, and it does track fairly well below. So there across the board are pretty much fewer devices in the market that are running these builds. But then if we look at exploit, it starts to track in a lot closer. And if we look at Rage Against the Cage and Zimperlich versus the top devices on the market, we see that it's tracking in very closely. Looking at the number of devices that have been patched against the HMM vuln, it's tracking even closer. And Gingerbreak being a new thing, is pretty much tracking right along the line. So we conclude that exploitability isn't a popularity contest, and neither is patching devices. There doesn't appear to be any correlation really between device popularity on the market and its likelihood of getting updates. That appears to be pretty uniform across the set of devices out there. So looking quickly then at overall vulnerability rates, if we just aggregate all the data on all the devices out there. Again, we have this massive Android release family chart here. There are, I haven't actually counted, but there are a number of, obviously a number of builds involved here. So back, what does the overall vulnerability decay plot look like in aggregate for each of these things? So for 2010-1807, this is basically what things look like, and it looks like around the beginning of 2011 we hit the 50% mark. Exploit had a much longer tail out there. We can see all the way into May 2011 before we see significant patch levels there. Rage and Zimperlich have had a very, very long tail here, and we haven't quite reached the 50% mark. That's pretty consistent across all the OEMs that we look at, and it's very consistent in aggregate. The HMM vuln, we've only seen about 25% of devices that appear to be patched against that at this point. And for Gingerbreak, the question is still open. We'll see where this goes. It's a little bit too new on the scale that we're looking at here. The half-lives that we're seeing to expect to see it drop very far. So again, here are the aggregate half-lives. We have 30 weeks for the WebKit vuln. We have 42 weeks for exploit, and we haven't quite reached that for any of the rest. So what are some of the things that we've taken away from looking into this? One of the things that we've noticed is that the compatibility test suite is a really good thing. In particular, more recently, it looks like the Android security folks have been committing specific tests to verify that builds have been patched against faults. So if everybody's running the CTS test correctly and they're shipping older builds, then they should have to cherry pick fixes down, even if they're on a stable release branch, in order to pass CTS. We think this is a good thing, and we think that there's some sign, given that spot testing some of these more recent devices reporting older versions shows that they have been fixed, that this is actually having an impact. And specifically, by the way, some of the vulns that are covered by the CTS have been cherry-picked down. Others that are not covered have not been cherry-picked down in some of these cases. So, and in particular, we think there's some opportunities here. We do think that there's an opportunity for tools to help track and manage patch levels, particularly going into the enterprise. As a lot of these devices are being active in the enterprise, we expect that people want to know what are the patch levels. They want to have they want to have their finger on the pulse of things. We also think there's an opportunity for independent security-minded ROMs, and these could be things that people decide to productize. These could be community efforts, but we definitely think that there's an opportunity out there for people to make sure that that there's an independent build that you can run on devices that will commit to being up to date with patches. Other opportunities, consumers are adopting smartphones at an insane pace. So we think that security is a must for the consumer market. Enterprise adoption is also happening, and enterprise requirements are likely to become key. We think there's an opportunity here for device security to be a competitive feature. We think there's an opportunity for operators to help drive this forward with the OEMs and insist that more attention be paid, that releases get out faster, that devices be updated, that we actually treat this like a patch cycle. I don't know. It's obviously speculation. Hey, these are conclusions that we've drawn from looking at this. Regardless of whether you've seen that be a feature in other markets, doesn't mean that there's a limitation here. I still think there's an opportunity for that to be the case, and I think there's an opportunity for somebody to decide that they're going to come out and they're going to tell that story and they're going to stick with it. We also think there's an opportunity here to kind of change the cycle. There's some indication. There have certainly been statements made that devices are more likely to start shipping with unlocked bootloaders. So far, though, that hasn't really started to happen. So I think actions speak louder there. Let's let enthusiasts be enthusiasts and do what they want with their devices, and let's keep bug hunting to bug hunting, and let's not tie the two together. Let's not tie the discovery vulnerability patch cycle to people's desire to unlock devices. Let's treat it like a security issue. And that's pretty much it. So, do you guys have any questions that we can answer before we wrap up? Sure. We didn't specifically look at custom ROMs, and it was one of the things that I actually hoped to do, but it turns out the actual prevalence of custom ROMs is very, very, very low, and there just wasn't enough data for us to look at it, so we didn't focus on it.
To make stricter standards that would allow the OEMs to
Yeah, I mean, I don't have a ton of insight into what Google has or hasn't discussed with carriers or OEMs or anyone else. I think the CTS is there to help make sure that device compatibility is maintained no matter what happens. I know that that's a story that they stick to, but can't really comment on the rest of it. Yes. Yes, it is maintained by Google. You can actually see CTS commits on the tree. They actually have their own tag hierarchy too.
Is this information available other than in this presentation? Like, is it publicly available?
It's not right now, and I'm not sure if it will be or not, but it is possible. Haven't really gotten there yet. Anything else? Yes.
All right, sorry to ask another question, but there's an Android bug where the device IDs weren't identified, or they weren't initiated, so that the devices were returning the same device ID. I was just wondering if you looked at that in research. What was it, sorry?
Could you clarify what you're talking about there?
Some of the builds, the random number that was basically built were initialized a particular value that is used to create a random number that supposedly uniquely identifies each device ID.
Are we talking about IMEIs,
No, not
Android IDs?
Android ID.
Okay.
So for a while there was a problem where they were all returning the same value, essentially the same as the Android debugger or the Android emulator.
Okay. Are you familiar with that? I'm not familiar with that. Sorry. Yes. I don't. I assume that they have some data. I certainly assume they have data on their devices, and they have an awful lot of devices that are communicating with the market and that are communicating with AdMob, and I assume they do some tracking there, but I don't have any specific insight. All right. Well, thank you very much.